All right, good evening. How are we all tonight? This is another fine episode of live training by Unity Technologies. What are we doing today? Let's start off with this proper. What are we doing? Tonight we're going to be extending the space shooter, the final chapter. This is going to be doing all of those stretch goals that we've looked at before. If we look at the done section, and we look at the done main extended, which is going to be the new name for the stretch goals, and we hit play, we're going to see that we've got our asteroids. We also have our shooting enemies. You'll have to tell me how the volume mix is with the game. I tried mixing it. If it's not good, I'll bring it down. So let's see these guys. You can see they dodge, they shoot, they move, and then we've got our multiple different types of asteroids. So the main scene. So here's our main scene, and with the main scene, as far as we had gotten it, we were firing, we were shooting, we were maneuvering. The background doesn't scroll, there are no stars, there's only one type of rock, only one type of asteroid implemented, and certainly no enemies at all. So that's what we're going to do. We're going to try to implement the enemies, we're going to implement the scrolling background, and we're going to implement the multiple different types of art choices that we can have for our asteroids. So I'm going to check on chat, see if there's anything important. Dovermo, I think that what you're asking is, does this take up where the last space shooter left off? Yes, this should pick up exactly at the end. So let's quickly change over here and let's look. So if we were doing modules and we were doing the space shooter tutorial and we had done all of these down to building the game, not necessarily extending to mobile, but building the game, the last episode here, then we would pick up what we're doing now. So what we're going to do is pick up directly from building the game, or actually really the one before, because it's irrelevant whether we're building the game or not, but from ending the game. So if you finish ending the game, then you can pick up where we are right now. Cool. So let's start off with adding the different asteroids and taking a look at the different asteroids. So we've got our main scene here, which is where we would have had left off if we were doing this on the Learn site. We have our prefabs folder, and in our prefabs folder, we have the one asteroid. So let's go ahead and we have 3 models. Let's go take a look at our models. So we have 3 models for the asteroid, prop asteroid 1, prop asteroid 2, and prop asteroid 3, all sort of slightly different in their shape. And the way that they look, and a little bit of a different color. And so we'll have the 3 of those. And remember the way that we created our original asteroid prefab. So let's go ahead and instantiate one. And I'm going to go ahead and I'm going to move that up on the Z a little ways out of the way. How about 8? And when we look at our asteroid, we had the parent game object that had all of our major components and had all of our logic on it. And we look at our child asteroid, and it has our mesh renderer and our mesh filter. So it has our art, but it doesn't have any of our logic. And this is also true of the way that we created our bolt prefab, where we have our bolt, and our bolt has all of the logic, and the VFX that comes as a child has the mesh renderer and the mesh filter. This makes it so that we can very easily change the artwork for our current asteroid. So I'm going to take the existing asteroid and I'm going to duplicate it twice. Let's go ahead and put these guys together. So we have all of our asteroids. And then let's go ahead and put one at something like -3. That looks good. And then let's put one at 3. So we can see our 3 asteroids that we've got there. And let's go ahead and pop these guys open. So we've got 3 asteroids and our 3 models. And so we can quickly swap these out. So we'll leave our asteroid as our straight asteroid. Let's take our asteroid number 2, and we can grab our prop asteroid model and drop that in as a child. Let's go ahead and delete, and it will tell us that we're breaking the prefab, which we want to do. And so now we've got this with a different artwork, different piece of art that we have there. Let's go ahead and swap to our scene view. And then we can hit F for frame selected, and we can see that we now have a completely different piece of artwork that we want for that. And then we'll do the same thing for our other asteroid. So let's go ahead and grab our asteroid number 3, drop that in, and then I'm using just Shift Delete to remove the existing artwork. So now we've got three different asteroids. let's go ahead and take a look at some of the things that we're going to have to change. We're going to have to change our collider, because the collider works. I'm going to do frame selected over here. Our collider is set up for that original model, and the other two models are slightly different. So the first thing we want to do is, remember, we're changing the capsule collider that's on the parent, not on the artwork. So there should be no colliders on the artwork. First thing I want to do is change the orientation of the collider. And capsule collider, y-axis, let's top that onto the x-axis, yep. And I'm going to go into top-down mode, and I'm going to get rid of perspective so that I can look at this slightly better. That looks okay. I'd say it's a bit too tall when we're looking at the capsule collider's height. So I'd drop that down just a little bit, and I might even offset it a little bit on the axis. Oops, how about the minus 0.1? Maybe slightly bigger. I'm just sort of, you're being rough. Maybe I'm too far over 0.05. But you know, irregular shapes in a regular capsule collider. So I mean, that's probably a little bit better. And then we can frame selected on the second one, and we can go ahead and take a look at the capsule collider that we have here. And again, we want to move that from the y-axis down to the x-axis. So now that we've got our colliders fixed for our asteroids, let's go ahead and rename these. So I want to have asteroid, let's make that one 02, and asteroid 03. So now we have our asteroids, we have changed the artwork, we have kept all of the material the same. The mover is the same, the destroy by contact, the random rotator, and since we've duplicated it, these are now going to act exactly like the original asteroid, except we're going to have different artwork. So we have our original asteroid, which we haven't really touched, so let's go ahead and just take that as an instance out of our scene. The other two we want to drag save as prefab, so let's drag these into our prefabs folder, and there's asteroid 2, and then there is asteroid 3. So we now have 3 asteroids. And just for the simplicity of the naming convention, let's make that one asteroid 41. Slippery fingers. So asteroid 1. So we've got asteroids 1, 2, and 3. And now we can get rid of the instances that we had. Shift delete. And they're gone from our scene. Photo Period is asking, why don't we explain why we aren't using a mesh collider? Well, partly that's covered in the original. I'm going to just give us something interesting to look at. There we go. Hey, look, image. We talk about why you shouldn't use a mesh collider when we talk about putting the collider on for the player spaceship. When looking at the player spaceship, we do have a mesh collider, and it is simplified. Let's turn off the mesh renderer. And so that's the simplified mesh collider that we're using. But during the original lesson, we discuss how it probably, for the sake of this game, could easily have been a capsule collider. Ejong 14, we'll talk about the sub-goals when we get into them. I mean, what I'm doing here primarily is just showing off the architecture. Maybe I didn't stress that enough. One of the most important parts about what I was just showing here was the architecture of the way that we made our prefabs was that all of the logic is on the top level. So we can easily swap out the artwork of the children without having to rebuild any of the practical portions of this game object. Cool. All right, so let's carry on. So we've now quickly updated the artwork that we've done for our asteroids. Now we need to update the script. Now the script is on the game controller. The game controller is the script that is controlling the way that the hazards are spawned, which are right now just simply a single hazard, which is our asteroid 01. And we need to expand this to be able to include multiple different types of hazards, whether they're just more asteroids, or as we see later on, we'll go ahead and use this expansion of the implementation for spawning our enemy ships as well. So let's go to our game controller, and let's take our game controller script, and let's edit that script in MonoDevelop. Now, it's actually quite simple. Our hazard is just simply a single game object. And we have a public reference to a game object. We populate that in the inspector. And then in our coroutine called spawn waves, we then spawn waves of these hazards. And we look at the instantiate, we instantiate our hazard, at a spawn position and a spawn rotation, and we calculate that spawn position and spawn rotation from making a random range, so it's the whole width of the top of the screen, and then we make sure that it's on the plane, the origin plane for Y, which is 0, and that spawn wave Z is outside of the screen. And the spawn values, we also make a public reference, and it's populated in the inspector. So if we quickly look back there on our game controller, we can see that there are spawn values. We've got 6, which is 6 and -6 are the edges of the board, Y 0, and we have Z16, which is off the edge of the screen. So we go from this corner to this corner on the game plane outside of the screen. The easiest thing to change is to change our game object reference to a game object array. And this means we can put as many game objects as we want into. Now, for the ease of coding and the ease of updating, let's call this array of hazards. And this means we won't have to rewrite our coroutine. So now we've got a list of hazards. And when we get down into our coroutine that spawns them, we then have to pick one from the list. So we can simply do that and make a game object reference. And that game object reference, let's call that hazard. And so now it has the same name for the thing that we're spawning. So our game object hazard equals, from our hazards list, we're going to pick an index number from our hazards list, only if I use the correct brackets. And so from our hazards list, we are going to pick a random range, and the random range will be from 0, which is the start index of our hazards list, to our hazards dot length. So this simply picks one at random from our list. And then it goes ahead and then we pick that same spawn position, same spawn rotation, and then we instantiate the hazard now that we create here from the list at our spawn position and spawn rotation. So that's the only update that we need to make to our script to be able to spawn different hazards. So let's go ahead and save this, and let's come back to Unity. Let's just double check. So we've got our game controller. We now have our hazards list. So let's lock the inspector. Let's grab our 3 asteroids, and then let's drop those on. And by locking the inspector, I can now drop all 3 of these. I can grab 3 items and I can drop them onto that list. Now I'm going to unlock the inspector. So now I've got 3 items to spawn from inside my game controller. Let's hit save. Let's hit play. And now we should get a variety of nice asteroid hazard rocks dropping down at us. So we don't have that identical set. We can pick. We can load that up with as many different types of asteroids or different hazards as we want to, and they can also have different. Different capabilities. If you wanted to start to get into power-ups, if you wanted to start to get into enemy ships, which we're going to see a little bit, you can put those into that same array as well, and they'll get mixed in with everything else. Yes, I will zoom in. Sorry, let me do that before I forget. There we go. Let's try that one. So the change was game object hazard. And then we added the line hazards random range. Let's add a space there. And back to Unity. Scroll the background. So scrolling the background is made up of 2 elements, a scrolling texture and a particle system. Actually, 2 particle systems. The first part is the particle system. Let's go ahead and take a look at it. So the first thing I want to do is just sort of turn off the background. And we're going to go ahead and grab these from the prefabs folder. And we're going to just go ahead and add them. We'll go ahead and take a look at the particle system, but particle systems themselves are very, very fiddly, and it would take us a long time to implement. So I'm just going to quickly go over the things that we've done. So I'm going to go into our prefabs, into VFX, into Starfield, and then I'm just going to drag that into the hierarchy. I'm going to go into the scene view, and then let's go ahead and frame selected. And we've got a little particle system down there. And it is below the plane. So it's -5, and it's just slightly outside of the game plane. And what it is, it's two series. One is big, a bunch of big, faster moving particles. And the other one is a bunch of smaller, slower moving particles. So when we look at that in the game view, what we end up having is some parallax-driven stars. They fluctuate a little bit, they blink a little bit. And so if we look at the component, the particle system, some of the important points is that we are pre-warming them. With a super long duration, we are looping them and we're pre-warming them. And so that's why when you first cut to it, so you go ahead and hit play, you'll see that the screen is full of stars. So if we didn't pre-warm them and we just had them running, they would start to flow from the beginning, so from the top. So we make sure that we pre-warm that loop. Otherwise, we would slowly get, it'll probably take a while before they come on. There we go, there's some stars. Shoot my way out of that one. So then what we don't want is to have that slowly appear. We want to pre-warm them so there's at least one entire cycle that is there on the screen. Then we pick a lifetime, a speed, and start size. And these are all a range. So there's a random number between two constants, so it picks a number between two values. And you need to play with these until you get something that you find comfortable. And so, you know, there's a lifetime. The shorter the lifetime, the quicker they'll disappear. And so there's a start speed and a start size. And we give them an emission from a shape. And this is the important thing, is that the shape is a box. And so it's like a giant box emitter that sits at the top of the screen and essentially cascades these particles down into the scene. And this is true for both of these particle systems. They're essentially the same emitter. They're emitting through each other. We change the color over lifetime, so they fluctuate between white and gray and black, so they blink a little. Also, they change their size over lifetime, and I'm going to open the editor so you can see this a little bit bigger. Different screen, so let's bring this over. So when we're looking here at size over lifetime, so they're changing size as well. And this is just simply by manually editing a curve. And there is a rotation over lifetime as well, which only makes sense when you take a look at the actual particle, which if we look at here, we can look at the material. Here, bring it up. Come on up. So the material actually has sort of spikes on it. So when they rotate, all of this adds, it's very subtle, but all of this can add up to seeing some life to the particles themselves. So I just closed the particle editor. So essentially that's a breakdown of the particle system. So you should go through, if you're curious, go break open that star field, take a look at the particle system, look at the implementation. The main goal that we have here is that you do larger, faster moving, but still slightly random stars at the top, you know, essentially at the top layer, and then you do farther distant stars that are finer grained, that are moving slower, so that when you play the game and you've got the star system, you get the sense that that the larger stars are moving quicker and that the slower stars are moving slower in the background. And just in case I monkeyed too much with that, I am going to delete that, and then I'm going to take the original star field and put that back in, just to make sure that I've got a clean copy. I could have reverted, but that works as well. Now the second portion of the background is, well, our background image. And for this, we need to find a way to move it on the Z plane. Now, I'm going to go ahead and read chat, and then I'll get back and we'll talk about moving the background image. What is the original format of these 3D meshes? We are importing FBX. So these are FBX models, but to a certain degree, we can bring in quite a number of different types of model types, including, I believe, OBJ. You'd have to check the documentation. Primarily, I see people use FBX, but need to look at the documentation for the various different types of importers that we maintain. We also maintain importing directly from certain application files like Max and Blender files and Maya files, as long as you have the application installed on your computer, because it leverages the application itself to the import. Yeah, Castraken, you can put a range. You can also make it a constant, you can make it a curve, you can make it random between two constants, and you can make it a random between two curves, which is actually quite amusing. You get quite a bit of versatility there. How do you open the particle editor? You type Open Editor under the Open Editor button, and you hit Close Editor, and you can dock the particle effect editor as well. And when you hide it, it will still be there. So it goes from close to hide when you have it docked. When it's undocked, it goes to close. Cool. All right, so we've looked at the star field, and now we need to go ahead and scroll the background. So let's go ahead and select that background. Let's go ahead and back to the scene view. No, I lied. Let's go back to the stay in the game view. So what we need to do is take this background, and we need to slide it along the Z-axis. Well, the first thing I notice is that this is a large image, but it's not that huge, and there isn't. Let's line it up to the bottom, and then scroll a little bit. And now we've cleared off and it's black. So the first thing that I'm noticing is the item itself is not big enough to do a lot of sliding with. And whatever trick we have to have some way that we can repeat this image. Well, what I'm going to do here is duplicate it very simply. The solution that we have for scrolling this background in this particular case runs a little bit of code that loops and loops its position. And so we need enough of the background so we can scroll it and have it move one complete rotation. So the first thing I'm going to do is I'm going to duplicate my background. So I'm going background and background one, and then I'm going to make the duplicated background a child of the original background. So there is one background parent object and one background child object. And the reason for this is I'm going to put the script on the parent object, and I want them to move both. The next thing I'm going to do is I'm going to click on the background in the scene view, and you have to do this because this doesn't work, what I'm about to do, if you just select it in the hierarchy. I'm going to do vertex snapping. So you have to tell the editor that you're working in the scene view window. So click on the background in the scene view window. The other thing you need to do is that sometimes you get the wrong one, the two objects here, but Unity will cycle through your options. So if you click on it and you get the parent background, click on it again until you get the child. And I've actually lost track of my orientation. So where's my player up here? Okay, it's frame selected on the player. I need to add this to the bottom. So clicking on that, I have the background, I have it duplicated. I hold the V key down for vertex snapping. I need to be in the transform tool and hold down the V key. There we go, pop. So now I have the background and I have the parent here, and that should be at 0. I've knocked that somewhere. Set of 0. Let me just undo to make sure we've got that correct. I've moved that. Yeah. There we go. That's where I moved it. So click on that, have our background, hold down the V key. Oh, come on. Hold down the V key, pop. That's what we're supposed to do. So I now have the two background images. And you'll see in a minute why, because of the direction of scrolling, we need to have it on the bottom side, not the top side. And you don't need anything on the top side, but you need it on the essentially the down range side for what we're doing. The negative Z down here. So the child, there's the parent. So let's save this. And then on the parent, let's add a new script. And let's just call this BG scroller. Now, remember that when we add component, it's going to pop the script into the root level of our directory, and we have a scripts folder. So let's go ahead and file that away. And then let's open the background scroller in MonoDevelop and go ahead and edit that. How is this driven? Well, we are going to drive this script in update using mathf repeat. What is mathf repeat? Well, remember, if we select something, we can hold the control and single quotes on Windows or the command and single quotes on Mac, and we can get in another window our scripting documentation. And with that, we can look up mathfrepeat. Now, this loops the value of t so that it is never larger than length and never smaller than 0. And it goes on to say that this is like a modulo operator, but it works with floating point numbers. For example, if you're using 3 for t and 2.5 for length, the result would be 0.5 because your length is 0.5, your number is 3, you're going to have gone all the way to 2.5, wrapped around back again, and you're now 0.5 into 2.5 again. So we're going to be using mathfrepeat to repeat the position of the background. And we are going to bring back up Unity. We're going to repeat the position of the background. And the reason it'll be seamless is that once it's gone through one entire length of the tile, it will then go ahead and pop right back to where it started from. So it will go ahead and cycle through these two tiles pretty much endlessly. So let's go ahead and take a look at how we're going to write this. We're going to need a couple of things. So our mathfrepeat, we need to set a new position. So we need a new position. Sorry, that's going to be a float. Let's give it a space. So we want a float, only if I can spell, called new position. And that float new position is going to be equal to our mathfrepeat. And what are we going to use to do input into the mathfrepeat? Well, we're going to use time.time, which is the time we are in the game. So as time advances in the game, so will the number that's being added to mathfrepeat. But we're going to need one other piece of information. We don't want this to be just time.time. We want to have some control over it. So we'll want some sort of scroll speed to multiply it by. Setting up our variables, we need a public float called scroll speed. Let's just copy and paste that since I've already written it and I need it to be exactly the same. Called scroll speed. And we want a public float, which is the length of the tile. So it's the tile size along the z-axis. So let's call that something silly like tile size z. And then we've declared our new position. Our new position is based on mathfrepeat with time.time and our scroll speed. So now we need to set our position, which will be our transform position. So the transform position of this whole background unit needs to equal some location plus a movement along the z-axis times our new position. Because a new position is just a float. That's telling us where we want to be, the new additional movement that we have that's going to repeat with that repetitive motion. So we're going to need some sort of start position. And then we need to add to it that vector 3 forward, because remember, that's down the z. Vector 3 forward is the same thing as saying x0, y0, z of 1. And then we can multiply that by our new position. So now we're going to have to also describe a private start position. Private what? Private vector 3 has to be a location. So private vector 3 is our start position. So we now have to set that start position, and that start position will be our transform dot position at start. So what we're going to do here is we're going to grab our start position, which is the transform position at start, which is almost but not quite origin. Part of the reason that we're doing this is we want to maintain that -10 in the y, keeping that transform of our background down below the game, because we're dealing within 3D space. I mean, we're not doing 2D, we're not dealing with sorting layers, we're dealing with actual physical location under our orthographic camera. So I don't want to start with a vector 3.0 at origin. I want to start with my start position, and I want to add to it along the z. Remember that this vector 3.forward is the same as just as 0x, 0y, 1 on the z. Then we multiply it by our repeating float. So let's save that. Let's come back to Unity. Oh, what have I done? And I forgot the tile size. Tile size Z. There we go. There's our tile size Z. So we are repeating, we're putting in time, and the thing that our length or size that we're repeating through is the size of the tile. So we've got our tile size Z, and we've got our tile size Z here. So we want to repeat along the size of the tile. So we come back to Unity, and now we need to look at the background scroller, and we need some sort of scroll speed. Let's just leave this at 0 so we can get an idea. And we also need some sort of tile size. We can see our tile size is actually the size of, because the quads are 1 by 1, the tile size will be 30. And that's where we want to repeat. Arguably, we could simply grab the scale, since this is a quad, and have grabbed that in start as well. But let's put that in manually. And then let's go ahead and hit save. Let's go ahead and hit play. We're probably going to be dodging our game controller. So let's turn off the game controller temporarily, and let's see if this causes anything to fail, because we're going to be turning that off anyway, because I don't want to be spawning any asteroids right now. So let's go ahead and hit play. Good. And so our background isn't moving because our background has a scroll speed of 0. But you can see as we increase it, it'll go faster and faster. And we want it to come down, so that means we need to have it as a negative number. And we don't want it moving too fast. You can see that at even 0.65, it's running significantly faster than our star field, which is also moving. So we need to sort of come back and find a nice slower speed. 0.1, it looks a little too slow. I would argue that this needs to be between 0.2 and 0.3, somewhere like that. 0.25 maybe. And then you get a slow sense. You're not being distracted by the background. The stars are all parallaxing a little bit. So somewhere in there, let's go ahead and hit stop. Remember, that'll reset our scroll speed. So let's hit 0.25, somewhere in the middle, save and play. Oh, how about negative? Okay, I should actually look before I just pop on, but I can feel my hip. Yep, negative 0.25. There we go. All right. So now we have a scrolling background. I'll leave the code up while I go ahead and read through chat. Manish Mittal has asked, why is scroll speed a float? Can it be an int? No, because then you can't get less than 1. Your scroll speed is either going to be 1 or 2 or 3 or 4. And to have more control over the speed that it scrolls, it needs to be a float. And then if you see that we used 0.25 to get that scroll speed, so it needed to be a float to be that slow, nice and gentle. Yes, putting a high speed is a boss level. Or when you, I mean, honestly, you could also do something where you can control that using code, where you're going to zip to the next level, and suddenly at the end of one level, you change your scroll speed to 5, or you ramp it up. Maybe you've got something that changes scroll speed over time, or -5, or 50. And so it changes over time, and so then it looks like you're zipping into something else, and you fade to black. I mean, you fade to black in a second or two, but you get the sense that you're zipping on to somewhere else. You'd also want to change the speed of your starscape. But I mean, you have full control over that in your code, so you can do whatever you wanted to. Who knows what you could do? You could also screw around with scale at the same time. So you get the sense where you scale and speed up the tile, and then you'd have to very quickly button out before something strange happened. But at least you could give it a try. Find some interesting effect that might work. Cool. Well, I'm going to carry on. So now we're on to enemies. Now, enemies is complicated, and don't forget that this is a long session. We were already pushing an hour, and we're going to push some more. Implementing enemies. Enemies are essentially more hazards, but they will have more complicated scripting. So let's go ahead and start with the enemy model. In our models, we have the enemy ship model, which is our cute little purple armed bandity thing. So let's go ahead and drag that. No, let's not drag that into the scene. That's the whole point. I don't want to drag it into the scene. So if I drag it into the scene, we'll start putting stuff on it. Here's what will happen. We'll drag this into the scene and go, oh, look, I've got a model. And then what do we want to do? We want to give it a collider and a rigid body. So we give it a physics rigid body, and then we give it a collider. And then the next thing you know, we are putting our logic directly on the model. And that sort of violates this attempt to keep our game objects and our logic separate from our artwork so that we can make quick and easy changes. So let's go ahead and remove this. Can't do that with the right because I don't know where it is. Just do a shift delete. It's gone. So let's create a new empty game object. And let's call this new empty game object enemy ship. So there's our enemy ship. And this will be built the same way that we built our asteroids and the same way that we built our bolts. Now let's reset this parent game object, and then let's push it up on the Z again about 8 units. I mean, we can't quite see it if you look in the scene. It's just a transform. And now we can go ahead and grab our enemy ship, and we make that a child of that empty transform. Now I'm going to keep my transform oriented with world space, and I'm going to take the model, I'm going to turn the model around. So that's 180 degrees. So I've got my transform still facing essentially at origin. We're about 8 units up along the Z, but I'm going to turn the model around because I want the model to start facing my player. So if you look in the game view, let's move this. That player text is in the way. Let's move it up a little bit farther. Let's grab that enemy ship parent. Let's move it up to 9 just so we can not have that text on top of it when we're looking down the game view. And our enemy ship is going to need some additional bells and whistles. So we've got some prefabs. We've got some engines. Let's add our enemy engines to the enemy ship. So he's got whereas our player has this nice little flamey engines, if we get down to them. So we've got our flame engines on our little player ship. Our enemies, they've got some sort of strange tech. So they've got some sort of dancing high-tech engine flames there. And on our parent, making sure that our parent game object is selected. So now that we've got our model and our engines as artwork, as children, let's start putting our logic together. So the first thing we want is our rigid body component. And so this will allow us to have the enemy ship participate in collisions. It'll allow us to use velocity, rigid body velocity, to move it, because that's the way we've been moving ships in this, even though it's in an arcade style. Let's make sure we deselect use gravity. Otherwise, of course, you know what happens when you leave gravity on? It will fall out of the game. Boop! It looks like it's disappearing, because remember, we're on an orthographic camera. What it's really doing is, oh, let's have just one of these, please. Okay. So what it's really doing is it's just falling down into the void until it falls outside of the clipping plane of our orthographic camera. Oh, come on, back where we were. So make sure that we have our use gravity deselected, and then let's put a collider around this one. I think that for this particular shape, it looks particularly round. So let's frame selected, and then let's add a physics sphere collider. And again, I'm going to take it off of perspective, and I'm going to go into top down so I can just more easily position this. I think it certainly needs to get bigger, but it also needs to come down on the Z axis somewhere so that we more thoroughly wrap up this model, which is somewhat front heavy based on its origin point. So let's go ahead and move that down. 0.3, that looks good. And 0.85, that looks about right. You know, we've got that whole ship surrounded. Not too much of it sticking off. Looks pretty good. I'll buy that for $1. So let's save this. And now we need to be able to blow this up. So let's take our destroy by contact script. Remember our destroy by contact script. Let's go ahead and open that up. We're going to be doing some editing with this anyway. So let's go ahead and take a look and remind ourselves of the destroy by contact. In our destroy by contact, we're finding our game controller because this is where we can record our points. And then we want to make sure we don't blow up by touching the boundary. This just to remind ourselves what we're doing here. Our entire game area is surrounded by a box collider. And when we leave the box collider, we are destroyed. So our bolts, when they leave the box collider, are going up, and our hazards and asteroids, when they leave the box collider going out the bottom, they get destroyed and they clean it up. The problem that we have is that when we instantiate things inside, they'll try to get destroyed by sometimes they can get destroyed by the boundary. So we don't want to destroy the boundary with our shots or anything like that. So we want to make sure that if the other tag is the boundary, we ignore it in this case of doing destroy by contact. And then we instantiate an explosion. Actually, this is not supposed to be here. I've updated this. Ignore this. We will get to that in a second. So we instantiate an explosion and at transform position and transform rotation because the hazards blow up. And then if we also have contact with a player, we instantiate the player's explosion and we end the game. And then finally we add score and we destroy all the objects that are related in the collision. And currently, and we'll see how this changes when we get into having the enemies start to fire, but currently the hazards are driving the entire game. The bolts that are being fired by our player, they're dummies. They just go shooting up towards the top of the screen, and they don't have any logic to destroy anything. They are bumping into the hazards as the hazards come down, and the hazards destroy anything they touch. They destroy the bolts, and they destroy the player. So this is our destroy by contact script. So let's go ahead and add that. We need to add our destroy by contact to our enemy ship. Bink. Now, this needs some explosions, and this needs some points. The player explosion is ready to go. VFX explosions. The player explosion, it's ready to go. It's got a particle system, and it has destroy by time, which we added to the particle systems because they need to be taken out of the scene when they're done playing. And then finally, it has that audio source for the explosion player. So when the sound of the explosion of the player blowing up. So we can add the explosion player prefab simply to the player explosion. Point value, why don't we make it twice what the asteroids were worth? So an asteroid is worth 10. So let's make the score value for our ships worth 20 because they're more dangerous. They shoot at you. But if we look at the enemy explosion, we'll notice that it doesn't have the audio effect. It's just the visual effect and the destroy by time. So we're going to need to add the audio to it. And the fastest way to do that is to go into the audio section, grab the enemy explosion, and pop that on. And that will create the audio source and reference the audio clip, and it will have play on awake, which we want to make sure that we have so that when we instantiate these enemy explosions, that it goes ahead and plays the appropriate sound immediately on that explosion. And then finally, after the explosion is over, destroy by time, we'll get rid of it in 2 seconds. So now our enemy ship has that destroy by contact. We have fixed our enemy explosion, and we have our enemy player, and we have our points being counted at 20. So let's edit one line here. Let's get rid of game controller add score. And the reason for this is just temporarily is that we're going to start getting errors. We're at that point where we're testing where our game was complete, and now we're going to start monkeying with it. And we want to start testing some things that are not complete. So we need to go ahead and get, I want to comment out game controller add score because otherwise, because I'm going to turn off the game controller, which we have turned off the game controller. And if we don't get rid of that, we're going to be in trouble. So let's come back to Unity. Let's save. Let's hit play. Ooh, look at that. Right now we've got our ship. It sits there. It's just got a visual effect. I mean, our background is scrolling, but we're not going anywhere. We can shoot. It detects the collision. I'm presuming you're hearing the correct sound. Here, I'll turn on my speakers because I've got my mic open and we'll just hear it. So let's go ahead and stop. Let's hit play. Ah, yes, that sounds nice. So now that we've created our enemy ship and we have him in the game, let's have the enemy ship shoot shots at us. So we're going to need to create on our enemy ship, on the parent, where we're putting our logic, a new script. So let's go ahead and add a new script. And let's call this one weapon controller. And again, don't forget that this is going to drop, I'm going to close some of these down. It's going to drop our weapon controller script in the root level. So let's go ahead and grab that and put that in the scripts folder. And then open up the scripts folder and open weapon controller for editing. Tish is asking, can you make patterns from your shots, like when the enemy comes out and rings? Yes, we can. Let's take a look at where we are at the end of this session, because we're already, more than an hour in, and I'm doing all right. I'm about halfway through what I plan to do. So, and I had a 2-hour session, so we're doing okay. But we can show how to do different shots as well once we get down to that. Yuvalda is asking, how can you change the speed of how can you slowly change the speed of the background? There are a number of ways that we can take a look at that. If you remind me during Q&A, maybe we can experiment with some. But you can slowly increment any value that you need over time. So you can slowly increment that value over time. You'll probably need a value of scroll speed. We can also use things like mathf move towards, and you can set a new value and you can move towards it. And also there's a number of curve, just math formula that you can use for slowly smoothing and dampening changes in numbers. Lord Drake Quadruple 4 asks, what is the point of destroying the bolts that are away from the camera as they aren't being rendered anyway? But they're still maintaining a spot in memory. They're still being processed, so they're still moving. So in the game loop, it's iterating through more and more and more and more laser bolts every frame and incrementing their transform. It's relatively lightweight, but you still can get to the point where you can shoot hundreds or maybe thousands of shots. And we do discuss that in the episode where we talk about making shots, but it keeps your hierarchy clean. It allows you to debug some things easier by looking at your hierarchy, but primarily it's that they are not wasting resources by having thousands of laser bolts just flying off to eternity in the void. And honestly, we probably shouldn't be destroying them. We should be pooling them. And when they leave the trigger, as opposed to being destroyed, that should call a method that puts them back into the pool. Cool. All right. Moving on to our weapon controller. So, I don't know if I'm going to need update. I don't think so. So let's get rid of it. Let's get rid of the annotations. So we're going to drive. I'll talk about this in a second, but we're going to drive this using invoke repeating. But let's start off with some of the boilerplate. We're going to be playing a sound when we fire our weapons. And as we know, we no longer have access through those shorthand helper functions that we had in versions 1 through 4. In version 5, we have to grab them ourselves. So let's start off with a private reference to an audio source, and let's just call that audio source. So this makes it easier for us to play our audio. And then let's say our audio source is going to be equal to a get component audio source. So that's a little bit of boilerplate that we can do in start. And what's the main thing we want to do? We want to fire our weapons. So let's create a function called fire. And in fire, what do we want to do? We want to instantiate an object at a rotation and a location. So we want to instantiate a shot. We want to instantiate it at a shot spawn position and at a shot spawn rotation. And we've seen that before. It's the same thing that we've done on the main ship. So we need to create some variables for this. Oh, I'm going to put these above private. So what we're going to need is a public reference to a game object. And let's call that our shot. And then we want a public transform, because this makes it easier. Let's call that our shot spawn. We could do a game object, but then we would have to look for shotspawn.transform.position and shotspawn.transform.rotation. And Unity, when we drag that shotspawn game object, will be able to find the appropriate reference to the transform component. So that just makes it generally easier. So we want to put down the reference to what we really need, and we really need the transform here. So we also want public float fire rate, because we want to control how fast we can fire, and a public float, which is the delay. I want to take a moment at the beginning of the game and not have the ship firing right away. So we have our fire. We want to instantiate our shot at our shot spawn position and our shot spawn rotation. And then we want to take our audio source, only if I can spell, and we want to say play. How do we call fire? I mean, we could call fire up here and just say, hey, we want to fire. Well, that's once at the start of the game. That's not going to be helpful. We can make a coroutine, and in that coroutine we could have a loop, and we could loop through it, and we can have a wait for our delay, and then we could have a wait at the end of a while loop. That would then be our fire rate. But Unity has something that's built in, which I thought I should let you know about, which is called invoke and invoke repeating. With invoke and invoke repeating, you can invoke or repetitively invoke a function. Now, there are other ways that you can do this, and I'm not necessarily recommending that this is the way you should do this in every game, but I do think that it's worth knowing, especially in a simple game like this, that we can have invoke repeating that can invoke a function. So let's quickly take a look at this in the documentation. So I'm holding down the control and single quotes because I'm on a Windows machine. For the people on the Mac, you want to hold down command and single quotes, and then you will get our documentation. Invoke repeating will invoke a method by its method name in the number of time seconds, and then repeatedly continue to invoke it every repeat rate second. So we've got the method name, delay time, and repeat time. So what we're going to do for using that, we'll say we want to invoke repeating. We want to invoke fire, has to be spelt the same way, with the capitalization. We want to do it after our delay, and we want to do it as often as fire rate. And we could get clever, and we could make a random range in here, and we can have fire rate be a range of time. If you want to do that, then feel free, and then you can have a slightly more random feel to it, whereas these are going to fire repetitively exactly at the same point every time. But for the purposes of example, it works just fine. So let's save this and let's come back to Unity and see what I've done wrong. Thought it didn't like that. Did I miss one of those? Oops. Shot spawn. Oh, show spawn. Yay! Learned to spell. I knew that was red. That shouldn't have been red. There we go. So if you look at our enemy, we've got our weapons controller. It wants a shot. It wants a shot spawn. It needs that fire rate and that delay. Shot spawn is easy. That's just another transform. So we can select the enemy ship and do a create empty. Because I have it selected, it's going to make it a child, and we can call this our shot spawn. Now it's going to be hard to see where this is. So I'm going to, again, go into my top down. I'm going to take it off perspective. I'm going to frame select it on the enemy ship. There's my shot spawn at the ship's origin. But for the sake of example, I'm just going to go ahead and grab that bolt prefab that we use for the player, and I'm going to stick that there at the shot spawn as a child. So there's our bolt. And I can use it to sort of figure out where I want it to spawn it. It's going to spawn it somewhere here between these arms. That looks kind of cool. OCD gets to me, what is that, about 0.5? So let's make that a clean 0.5. Now, remember our bolts, they always shoot and move down their transform forward along their positive z-axis. And currently, that is the positive z-axis for our bolt is facing up. So we want to take our shot spawn and, rotation please, turn that around 180 degrees. Whoops, that's because I moved the bolt, not the shot. All right, let me send that out. The shot spawn, let's do this again. Crackers, who's running this show? Okay, so with the shot spawn selected, make sure we adjust that on the z-axis, and about 0.5 seems to be correct. Now, the shot spawn, not the bolt, the shot spawn also needs to be rotated 180 degrees. Because when we rotate it 180 degrees, now the child object, which is going to be taken, because remember, if you look at our code, we're going to use that shot spawn's position and the shot spawn's rotation to instantiate our shot. So we have our shot spawn, its position is there, its rotation is 180 degrees, so it gives us that leading down on the z-axis. So that's our shot spawn. Now we need a bolt. So with this bolt, we've got one here. Remember, again, it's logic on the top, and that's the logic that we want, VFX on the bottom. This VFX is driven by the material that's applied to the quad. Remember, this is a flat quad. Let's get back to perspective. So it's a little flat quad with a material on it. And that material is bolt orange, this down here. So what we can do is we can duplicate this, and we can make this the enemy bolt. And we can change its material. We can change the artwork on the material. So we've got another laser. We've got two. We've got one that's orange and one that's cyan. So I can go ahead and select the cyan bolt. So let's go ahead and change the name of the material and change it from orange to cyan, or call it enemy, whatever you want to do, rather than color. So we now have FX bolt cyan, and then we can come up here and change on the instance, and we're not changing the prefab asset down in here. We're changing this instance that we have instantiated up on our spaceship, and we can change the material to cyan. Now, this bolt needs to destroy the player as well. Remember what we were saying about the original bolt prefab. It's got a mover script, it's got a capsule collider, it's got a rigid body. That's still true of the instance that we have in the scene, where we've got the mover script, the capsule collider, and the rigid body. So our enemy ship is going to fire this, and it's going to go downstream, it's going to hit the player, and it's going to go right through. Because they're both triggered colliders, and there's no logic on either the player or on the bolt to destroy the player. So we're now going to need to update this enemy bolt. So let's make sure that we understand what's going on here. Let's make this bolt enemy. So we've got this enemy bolt. So let's add the destroy by contact script to it. This is imperfect in a couple of ways. Now, there probably would be a way that we could completely rewrite this particular script, but I sort of want to reuse the assets. I also want to continue to keep this entire project on about the same level for programming and complexity. So we're going to leave this the way it is, and we're going to do some modifications to destroy by contact so it works both for the hazards and it does also work for the enemy gunshot as it does here. The issues. First, it's built with two explosions. This was designed to blow up an asteroid and potentially blow up the player. Let's go ahead and edit this so we can take a look at it. And so remember, we've got our on-trigger enter call, and if it's the boundary, we ignore it. Then we instantiate an explosion. And then if it's the player, we go ahead and instantiate the player explosion and do a game over. But we don't want our enemy bolt to have a secondary explosion. It's not the spaceship, and it's not the asteroid. So one of the solutions, the other thing we don't want is we don't want it to score. We don't want to get a score value from every one of these bolts. Well, leaving the score value as 0 is very useful. So it's going to add a score value of nothing, so our points won't go up. But our explosion is a problem. The second problem is it will destroy the enemy and the asteroids as well as the player. Because right now it's just doing a destroy by contact. So it's going to go ahead, and if it hits anything, and remember the way this game works is that these bolts are going to be moving faster than either the asteroids or the other enemy ships or anything. So as they come down and they're firing indiscriminately, these bolts are going to bump into asteroids, they're going to bump into other ships, and they'd start just decimating their own team, which we don't necessarily need. So let's go ahead and make some small modifications to the code. The first one is that we want to ignore the on-trigger enter if we're the boundary, or if the other .tag is the same as enemy. Now don't forget there's another way that we can do this as well. We can also say if other .compare tag boundary, or other .compare tag enemy. And this is ever so slightly more performant. The other thing that we also want to do is around our instantiate explosion, we now have to test this. So if our explosion is not equal to null, so if we have an explosion, then we get wonderful code completion. Thank you. If we have the explosion, then we instantiate it. So what we can do here, so let's save this, is we can make the decision about our destroy by contact on the enemy bolt that we just simply don't put an explosion here. If there is an explosion, like we do on the asteroids, good to go, we'll instantiate it. If we have an object that doesn't need an explosion, then we won't put it on, and it will be tested with against null, and if it's not null, then we instantiate it. If it is null, we just ignore it. So this means now we can very simply just put in our player explosion. VFX prefabs, explosions, player explosion. And we want to leave the other two empty, the other two blank. Now, looking back at the script, we are comparing the tag enemy. So this means we must now take all of our prefabs and give them enemy. So this means our enemy ship needs to be tagged enemy. Now this particular project has enemy predefined. If you were to run this from scratch, rather than download the package off the asset store, you may not have a tag for enemy. So you may need to come into the tags and layers and create a new tag and then call it enemy, which we already have. And then once that tag has been created, you need to then go back and you need to tag your enemy ship. We need to tag our bolt as enemy. And then also we need to take all three of our asteroid prefabs, and remember multi-selection editing, and we want to tag all of these as enemy. So we've got 3 enemy asteroids. 1, 2, 3. Enemy bolt prefab and enemy ship. So now we want to take our bolt enemy and we want to make this prefab. It's getting a little bit nasty here in our prefabs folder. Depends how organized you want to be. But we could create a folder and call it asteroids. And again, I'm selecting the prefabs folder and then create folder bolts. And then we can file 3 asteroids away and file 2 bolts. Delete the... let's select it to make sure we have the right one. Bolt enemy, yep. So we've saved it. Try shift delete, it's gone. And then our enemy ship, we now have a shot. We have shot spawn. We have a fire rate and a delay that we can put in. So we want to know our shot. Our shot is going to be the enemy bolt. Our shot spawn is going to be our shot spawn. Our fire rate, what is our fire rate going to be? 0.5 seconds? Can't find my magic number, so I'll make them up. Nah, let's just do it a little bit longer than it. We'll say 1.5 for the fire rate, and then delay. We only delay a half a second because we want them to fire as soon as they get on the board. So we're calling in our weapon controller script, we're going to be calling audio.play. So if we look at our script, remember our weapon controller, it instantiates the shot, and then it calls play on the audio. So we also need to make sure that we have an audio source with that weapon sound on the enemy ship. So again, let's come back to our audio. Let's find our enemy weapons, and then we want to drag that onto our enemy ship. And we want to make sure play and awake is turned off, because we don't want play and awake. We want to only have this play when the ship fires a shot. Okay, I'm going to come back and look at chat. We didn't change the direction the bolt moves, Ejong 14. We changed the orientation of the spawn, of the shot spawn. So I've rotated shot spawn 180 degrees, so now it's facing down the negative Z, but we instantiate the bolt here and it moves along its local Z, so it comes straight down. Cool. All right. Let's do some testing. I think at this point we want to uncomment destroy line in destroy by contact. So let's save that and let's come back to Unity and let's activate our game controller. Turn that back on. Unreachable code detected. Possible mistaken empty statement. Oh, yes, semicolon. Duh. Now I understand what that was all about. Cool. All right, so we've reactivated our game controller, and then let's save and play, and hopefully this will work. Well, hit close me up, that's for certain. Yeah, that seems to be working. Ooh, something's wrong there. We forgot to set trigger as my guess. Enemy ship. That's embarrassing. We forgot to set trigger. So back there, when we set the sphere collider, let's set that to being a trigger rather than a physics collider. Okay, so it's shooting at us and we're blowing up correctly. Ooh. And if you notice that just because of the nature of this, you can blow up their bolts. So now that we're in perfect location, I fire faster than it does. I can... It's a bit fast to see. Anyway, so yes, that seems to be working. Yay! I see a question. What is the significant difference between using GameObject.CompareTag tag versus GameObject.tag or other .tag? A very, very, very small amount of performance improvement, just not very much. Okay, let's talk about moving the enemy. So first thing I'm going to do is, on the enemy ship, is turn off the weapons controller, because I don't want it shooting at us while we're practicing. Let's go back to where we were before and deactivate that game controller, and go back into the script and deactivate the add score, just so that we're back into testing mode. Now, we want to do some moving. So the first thing I want to do is on the enemy ship, I want to drag that mover script onto it. And I like to keep my things bunched together, and my scripts are up higher, so I'm going to move that mover script up so that it's up with the other scripts, and then leave the audio source down there at the bottom. And let's match the speed, because one of the mechanics that work with this particular game is that all of the hazards are moving the same speed, so they don't bump into each other, and we don't have to worry about them blowing each other up, or, now that they're tagged enemy, moving through each other. So our asteroids are all moving -5 on the mover. So let's take our enemy ship and let's move it -5 as well, so we're all moving the same speed. So let's save, and let's play. Woo! So it moves, and it goes off. So that's not bad, you know. So it's moving. It's moving the same rate of all the other ones. Does it blow us up when it touches into us? Boom! No, but that's because we have the game over disabled and we get an error. So we can't test it blowing us up because we're going to get a null reference exception by saying we don't know what to do at that point. So we now need to worry about maneuvering and maneuvering this enemy ship. The maneuvering that I want to do is relatively simple. Enemies are going to appear randomly along the top edge, and then they're going to fly forward. And what I want them to do is, somewhat randomly, just do a little dodge maneuver, a little gentle move to the left, a little gentle move to the right, and then continue to carry on straight forward, and then a move again. And this makes them slightly harder to hit. This gives them a little bit more life, so they aren't just another asteroid. Otherwise, they'd just be an asteroid with a gun, with a different skin. So they have some more life to them. So let's go ahead. It's actually relatively simple. They aren't patterns like some people have been asking for. They're just little jinks to the left and to the right. And there is a bit of a trick to this, which if you end up trying to master this game, because it is so terribly difficult, it'll give you a little insight and give you some small advantage when you see how this works. So let's create a new script. Add component, new script, and let's call this one evasive maneuver. And again, I'm going to pop that up one, move that up in the hierarchy so it's up with our other scripts. It's going to be put into the root, so let's file it away, and then let's open that up for editing. So what we're going to do here is we're going to start our ship moving. With that mover, it's going to set its initial velocity, and then we're going to take over with this evasive maneuver script. Now, this is a bit big and a little bit complicated. It'll probably take us up right up to that 2-hour mark and may push us over a little bit. It's the last couple of pages to go, so let's see whether we can finish this off in 15 minutes, and then we can go into some Q&A. So the first thing I'm going to get rid of these guys because I don't like them. And just for consistency's sake, let's go ahead and fix the brackets. We want to evade. We're going to evade by setting a target value along the x-axis and moving towards it over a period of time. So this particular function also needs to be a coroutine. So we need to return IEnumerator. So we've got IEnumerator evade, and we're going to have a mini loop inside this. We're going to have a wait at the beginning, and then we're going to have a little mini loop that'll carry on until the ship is destroyed. Again, if we've got a coroutine, we need to start that with start coroutine. And what's the coroutine we're going to start? It's going to be evade. And that one does get a semicolon. And I actually had to think for a second, oh my God, it's a semicolon. Have I made a mistake? No, thank goodness. So we start our coroutine evade. What's the first thing that we need at the top? I want to have a wait. I don't want the ship to evade immediately. So we're going to need a value to have it hold on. So let me give a public vector2, and let's call that start wait, following the same sort of nomenclature that we've had from the rest of this project. Now, why am I using a vector2? We could create our own custom struct, or we could create our own custom class, or we could just have start wait min, start wait max. But I want it to be a range that we can randomize using our random range. And so I'm finding it, in this case, it's nice and compact. I'm going to make a vector2. I've got 2 little fields. I'm going to go ahead and use them. The first thing we want to do in evade is we want to yield, return, new, wait for seconds. And that's going to be a random range from our start wait x and start wait y. So we can set our x and y values in the inspector, and then we will wait some random amount between start wait min and start wait max, or start wait x and start wait y. And then we're going to get into our little loop. So we're going to say while true. So this is our loop that's going to take us through our dodging maneuvers. So what I want to do is set a target maneuver. So let's create something to hold it. This is going to be private. So we want a private float, and it's going to be target maneuver. And then what we're going to do is set target maneuver. It's going to be equal to some random range, which we'll talk about in just a second. And then once we set our target maneuver, we want to yield, only if I learn how to spell it, yield, return new, wait for seconds, yay, nice and long. And then, so we've set our target maneuver, we're going to wait while it does some maneuvering. Then we want to set our target maneuver back to 0. So we don't have a maneuver target that we're going for. And then we're going to wait again. For some period of time, and then we go back through our loop. So now essentially what we've done is we have a wait at the beginning, we have a loop where we're going to go through our dodges, we will pick a random target maneuver, it could be maneuver target instead of target maneuver, which was a point on the x-axis, so it's going to move to the left or to the right. We wait while it's doing the move, we then set it to being nothing, and then we wait, and then we'll loop back and do it again. So at the speed of this game, we might get 1 or 2, maybe 3 out of push maneuvers in an entire cycle before the enemy ship leaves the bottom of the screen. So let's get some of the things that we need for this. We're going to need a public float. I'm going to call it dodge, and that's going to help us pick our target maneuver. And then I want a public again, vector 2 for our maneuver time, and a public vector 2 for our maneuver wait. And just for clarity, I want to just keep all my vector 2s together. So I'm going to move that dodge to the top, just because I like it, better for my brain. So I've got a start wait, a maneuver wait, and a time vector 2, and then I've got the dodge that we have that helps us pick our new maneuver. So what is our maneuver? It's going to be a random range. It's going to be a random range from 1 to a value that we pick for dodge. I'll try to step you through this. A teeny bit complicated, but it should make a little bit of sense. I'm picking a number between 1 and a max number that we're going to make in the inspector. So it's always going to be at least 1 or more. And then I want to multiply this random range by negative mathf sign. And the mathf sign of the transform position x. This seems a bit weird. It's a trick. One of the problems that you can have is that if you've got your ship flying down inside the game, let's grab it, and you have something over here, it's coming down, on the X-plane, you don't want it dodging off. Well, we're going to clamp it. But there's a tendency that as these things dodge, that they will dodge and get bumped up against the edge. By looking at the transform's position, and remember that there is a 0 line down the middle, we're negative on one side and positive on the other, going from -6 to 6. By doing this, if you're on the negative side, you'll always dodge inwards. If you're on the positive side, you'll still always dodge inwards because of using mathf sign. So this is partly done to keep our spaceship there inside the screen and to not make it look silly and to generally tend the enemies towards the center. But here's the trick. if you're having a tough time and you can't win this game, realize if it's on the left side, it's always going to dodge right. And if it's on the right side, it's always going to dodge left. But it works. And it gives them a sense of life, and you don't get them clustered up against the edge by being random. And it's relatively straightforward without having to try to do some sort of silly AI thing. Now, then we wait on our random range. And our random range is simply going to be our maneuver time dot x and our maneuver time dot y. And then we set our target maneuver back to 0. And then we have our wait time. So our random range is going to be, oh, sorry, I forgot random range. Let me just fix that. So that is the new wait for seconds is a random range. Here I'm filling in parentheses. I'm not looking at what's outside the parentheses. From maneuver time x to maneuver time y. And then we wait another set of seconds, which is going to be a random range from maneuver, was it wait? Maneuver wait x and maneuver wait y. So now we've set this float that gives us a direction on the x-axis. And remember, our ship is moving using physics, so let's change this to fixed update. So now in fixed update, we actually have to change the position. And also, we're going to start using the rigid body. So we need to avoid our lack of helper shortcuts. And so we have to grab that rigid body directly. So let's make a private rigid body. Let's call it RB. And in start, at the beginning of start, let's say RB equals get component rigid body. And that will allow us to use RB throughout all of the rest of what we're going to write. So we can say our float, we want a new maneuver, and that's going to be, so this is the new maneuver. A new maneuver is going to be another math F, move towards. There's a lot of, one of the things someone was asking me what are the goals are here. How many math Fs have we used? Math F clamp, math F, say that 10 times fast. Math F move towards, math F sign. What other math Fs have we used? Since we've used a bunch. But it's important to remember math F repeat. I knew there was another one. Is that it is a very helpful set of math functions. And they can help us with smooth damping. They can help us with clamping. They can help us with purl and noise. They can help us with all sorts of things. So in this case, we're going to use math F move towards. So we're going to slowly move towards. Do we know move towards? Let's take a look. Essentially the same as mathf.lerp, but instead the function will ensure that the speed never exceeds the maximum delta and negative values pushes it away from the target. It's just a very simple way of moving something from one place to another without having to get into writing your own lerp, which can often, mathf lerp can often be misunderstood and misused. So we're using mathf move towards. What are we moving? That's what I was looking at. Let's go back there. So you have your current float, what you're moving towards. You have where you're moving it to. So what I'm moving it towards, so that's target. And then what's the max speed that you can move it. What are we moving? We are moving our rigid body velocity dot x. So we're taking our current rigid body velocity x out of that x, y, and z. And we are moving it towards our target maneuver, which is what we set in evade. And then how fast are we going to do this? We're going to move it using time.delta time. Now I want more control over the speed at which we're moving, more than just the time it took for the frame to render. So let's multiply this by something that we will call smoothing. So we're going to need a public, let's put this up with our floats, public float called smoothing. On the next line, we then want to set our rigid body velocity to be equal to a new vector 3. That's going to be made up of an x, a y, and a z. And what is the x? That's our new maneuver. So we want to move towards our new maneuver. We're moving towards our target maneuver. The new maneuver is moving towards the target maneuver. So our X is the new maneuver. Our Y is 0.0. And our Z, what is our Z? This needs to be our current speed because we don't want to change the speed we're going downrange. We want that movement, that rigid body velocity down the Z to be always the same. Otherwise, it falls out of the game mechanic. So we're going to need some way to grab a hold of that. So we're going to need a private float current speed. And then in start, we need current speed to be equal to our rigid body dot velocity dot z. So we're going to start using that mover. Remember we said the ship would start moving using the mover script. So that'll give us our initial rigid body velocity and our original rigid body velocity along the z. We then are going to capture that in our current speed. And then for setting our rigid body velocity, we make sure that we set that to our current speed. So we'll always be going down the Z plane, the Z axis at the same speed. Now we need to clamp it. So here's the only problem that we have now, is it is unlikely that, considering we're using the sign, that mathf sign, to keep us dodging always towards the center of the screen, it is highly unlikely, if at all possible, that we would ever leave the screen. But just in case, we need to clamp the rigid body's position inside the screen. Now, where did we see this before? When we are clamping the player ship to the screen. So if we look at our player controller, just open it up, please. Remember, we clamp our rigid body position inside the screen using our position X and boundaries. So we need to do the same thing here, where we've got where we're going to use the boundary class. So we've got we'll have a public boundary, and then we'll have the same clamp as well. So let's create a public boundary. Let's just call this boundary, and then we will use the same clamps that we had before, which will be mathf, and here's some more mathfs. Clamp. And then we want to make sure that we're on, for our Y, we're still in the center, and then mathf.clamp for the Z. Now, I think we're indented one too many. Yep. And what are we clamping it to? We're clamping our rigid body's position X to our boundary.x min and our boundary.x max. 0 on the Y, and then our rigid body position dot Z is going to be clamped between our boundary.z min and our boundary.z max. And remember, no comma after the last line. That will keep us inside. That may be a little bit of an insurance policy, but it's probably worth doing. And lastly, let's add that sizzle. Remember, when our ship is moving, we get tilt back and forth. And let's go ahead and add that same tilt to our enemy ship. So let me just put this guy back at 0.8. Or do we decide 0.9? Doesn't make a difference. There we go. So we're going to need another float, another public float called tilt. And the last line that we'll write here in our fixed update is our RB dot rotation. Oh, I don't like the fact that we aren't getting code completion. Oh, and we need that semicolon. So RB dot rigid body dot rotation needs to be equal to our quaternion Euler. And our quaternion Euler is going to be 0 on the x, on the y, and then our RB dot velocity dot x times that negative tilt. All right, let's just have a quick look and see what I've made as a mistake. Something's wrong. No, nothing. Wow, what a miracle. Okay, now, in theory, that's done. So let's return to Unity and save. I want to make sure all my components are together. I've got that audio source down at the bottom, so I've got evasive maneuver at the top. We're going to have to populate evasive maneuver. So we've got our boundary at the bottom, which I just know offhand is we're 12 units wide, 40 units tall, so we're -6 to 6, so 12 units, and then we're 20 to -20. And we just know that from earlier on in this lesson, so our x is going to be -6, and then 6, and then our z is going to be -20 and 20. So that's our boundary. And then things like dodge, I sort of said 5, and that was just somewhat of a magic number. If you should play with it until you get a dodge maneuver that's working the way that you want it to be. And smoothing, which is how quickly it moves into the dodge, I'd sort of come up with a magic number of 7.5. But you should go ahead and experiment with these to give your game the feel that you want. And tilt, I sort of picked up by playing with it because the ship looks different from the player ship. And if you tilt too far or not far enough, you don't get very good lighting on it. And the main hero lighting looks great on the hero ship, and frankly, it doesn't really work with the angular geometry of the enemy ship. So play with it and see if you can find a good tilt in there. Start weight before you maneuver, a half a second to a second and a half is half a second to maybe a second would be good. So that doesn't ever immediately start jinking. If you find that it's not good enough, you get rid of the start weight or make it very small. The maneuver time, how long it's going to be in the maneuver, in changing this maneuver point, I thought sort of between 1 to 2 seconds. It was just off the top of my head. And the maneuver weight, the same thing. I should have thought between 1 to 2 before it does another maneuver. But if you want it to be reacting faster, then you can go ahead and change those numbers around. So now we've got this enemy ship. So let's go ahead and make a prefab. Let's drag the enemy ship into the prefabs. So now we have our enemy ship prefab. Let's remove the instance. I'm going to double check by selecting to make sure I've got it. Yep, it's gone blue, so I know it's there. And by selecting it, I can see that we've saved it there here in the hierarchy. So Shift Delete, and away it goes. It's gone. So let's go ahead and turn the game controller back on. Let's turn the enemy ship's weapon controller back on, which I almost forgot. We've turned that off, so we need to make sure our weapon controller is on, our game controller is on, and then let's add the enemy ship as a hazard to our hazard list. And so let's save that. And then also we need to come back to our script, and let's turn back on our game controller add score and save that. So everything is back on. Now, just a quick mention about ratios. On average, we're going to get 1 enemy ship and 3 asteroids, and the asteroids themselves are going to be equally distributed. So we're going to get an equal distribution of these 4 hazards. Now, the random numbers are random, and I've had entire screens. I've had 10 entire screen full of enemy ships or no enemy ships. So it's entirely possible to, with this particular selection, is that we have 4 items and we're picking randomly from those 4. So it will tend to pick an even distribution of these, but it's not necessarily going to be true. So if you want a different distribution, you either need to weight your list. Now we'll have twice as many enemy ships because we've got 2 enemy ships. We have a chance of picking them twice. Or you need to pick a more clever distribution system than just picking one of these at random. So let's save. Let's hit play and hope it works. Yep. Oh, and we're firing and we're jinking too. Look at that. Maybe we should just get out of the way and let them do their stuff. So that'll be a, and it looks like we got some double points for that as well. Ooh, out of the way. Oh, bah. So yes, you can see that they're maneuvering around and they're tilting a little bit. Try not to blow up the ships. We try to get myself some asteroids out of the way. Oh, and see, no asteroids, or no enemy ships, just asteroids. Yep. You know, so they're maneuvering, and so I mean, this is one of these things where we're not looking for hugely complicated AI at this point. And there was me using the inside knowledge. I knew that it would not jink towards the outside. So I knew I could be far enough out and I was safe. So it was a bit of a cheat there. So that's it. If you have any questions, I'm going to write in Q&A starting now. Anything after that, I will pay attention to. So Eatjong14 says, what would be involved in getting an enemy to spawn from the back as well as the front? You mean coming from behind? If you wanted them to come up from behind, you would need a new line in the game controller. So when we're instantiating here, we have only one spawn position. And so that picks a line somewhere along the top. So you'd have to go in at this point and say my vector 3 spawn position equals, and then you're going to need some logic in here that says, you know, if, actually you'd leave that. What you'd say is something like, you know, flag, Boolean flag equals, you know, random dot value. And, you know, if just give me 2 seconds. I have it written down. Where'd it go? You see, I don't bother remembering anything if I write it down. There we go. That's it. Bool orientation, random value greater than 5, because the random value is between 0 and 1. So what you would do is, you know, if, what was that? Let's just try this whole thing again. Bool flag is random value greater than 1. So that's a true false. That's an if statement. And so we've set flag, and then you'd say, you know, if flag. And then this is, sorry, I'm not going to answer your question directly, but, you know, if you had something like that, let me just get this working. Then you would pick a different random range. So this is me going around in circles, probably a little bit tired. But essentially you're going to have to choose a different Z value, which is what I'm getting to here. Just the way that we do a random range here, but you'd need to have something that is either in front or out. Whereas right now our spawn values are 16. So it's going to have to be 16 or minus 16 to come up the other way. But you're going to need another layer, which not only does this have to be 16 or minus 16, whereas something like spawn value dot Z, you know, is either going to be 16, you know, or this is not even real code, but you get the idea, or minus 16, and then you use it, or you come up with a different word. But then you're going to need to instantiate the hazard, and then you're going to need to change the speed of the mover and the orientation. So somewhere in here, you're going to have something like reverse direction. You know, I'm making this up as I go around along. And you feed it a game object, feed it the, where's the instantiate? Game object, clone, equals. And then you have to cast that, which I'm not going to do. No, something like that. And then you have to do your clone direction, clone.transform dot rotation.y, you know, equals 0. You see, you want it to go up, and then you'd have to get the mover, get component mover, clone.get component mover. You know where I'm going with this. Something like that, you know, and so you're turning it around because you have to do a reasonable amount of junk, and get the ship or the hazard to come the other way. I mean, it's going to break the game mechanic that you have, which is, first of all, the player will never be able to fire down. So the only thing they could do is avoid it. They'd have to dodge out of the way of the things coming from behind. So you'd have to change a lot of your entire gameplay mechanic. So you may find it easier to re-roll the entire game logic of where things spawn and how spawns are calculated. This particular game and a lot of the simplicity of the code is really based on the fact that the hazards just fall from the top, never leave the sides. And you know, everything that's a hazard comes down, and everything that's a player goes up. But anyway, so that hopefully that's of some value. I don't know, off the top of my head. Kilroy512 says, "How is random number generation handled in the engine?" Well, it's a normal, sophisticated pseudo-random number based on an initial seed. So like most implementations of a random number generator, there is pseudo-random code going on, and if you can pick a random seed. The advantage to that is that if you want procedural material and you want to be able to completely replicate that, then as long as you know what your random seed is, the random seed is handled underneath the hood. So if you just want a random number, you can just say, please just give me a random number. It's worth looking at the random class. Remember, select something, command or control, single quote, and then you just get the random class. And this will talk about the various different things you can get. Random range is what we were primarily using. You can set the seed. Random value is between 0 and 1. So that's what we also used. But you can do things like the tumbler has random inside unit sphere, which gives you a random vector 3. Random inside unit circle gives you a random vector 2. And then some of these, like on unit sphere, gives you a direction, but with a uniform magnitude. So it's worth looking at the different randoms you can pick. But most people use random range or random value, and you can set the random seed. But if you don't, the random seed will work by itself. And it's worth just reading up on the random seed, partly because it talks about random number generation. MDYRCZ4. Why is this game made in XZ view and not in XY view? It's just a choice. In being in 3D, you could do it in any of the views. It just seemed convenient. 3D has a tendency for people to be looking, when you're looking top down on something, to be looking down the y-axis on the XZ plane, and 2D has a tendency to be up in front of you on the XY plane. Just generally the way that those spaces work, and so we followed the typical analogy for a 3D space, because it is technically a 3D game. You could program it so that someone else just mentioned it down below. I can see math have to move towards. You could, if you wanted to have it tend towards the player, rather than saying, just get rid of all of this. In evasive maneuver, instead of dodge and random range, picks a number somewhere to target. You could say our target maneuver equals, you'd need a public game object, public transform player. Let's make it player transform. And then you could say it's target maneuver is player transform dot position dot x. Should work. Let's find out. Let's see what happens. They don't seem to be moving at all. Oh, because I've got an error. What's the error? Oh, because I haven't added the player. Silly me. Oh, and we can't because it's we'll have to do one of those silly finds. So that's going to be a private player transform. And then start, it's going to be player equals game object dot find. No. Game object dot find with tag. Dot transform. And do we have the player tag player? We do. Ah, they are coming after me. Probably just the way that code is randomized or something. That because those certainly jinked straight at me when they got the code correct. So anyway, silliness, totally silly. Yeah, they're coming after me. So that code is working. There's something else that's in the randomizing that's not making it as helpful as possible. They're all moving a little bit somehow. Anyway, you get the idea. My two sky. Is there any better zero axis in 2D games? X0, Y0, Z0? No, it really is up to you. In general, 2D games run along the XY plane as if it's in front of you, and 3D games run along the XZ plane as if it's on the ground. I'm reading that Jong14 is saying, would it be difficult to get the explosions that the enemies create to continue moving down with momentum rather than explode statically? Yeah, you just would have to you'd either have to have a script that updates the transform position every frame, or you would need to have an object with a rigid body on it, and then you would give the same rigid body velocity to the game object. Or thirdly, you could look at the explosion VFX and try in the particle system to give the particles a velocity based on the velocity of the ship. But then you just need a reference to the particle system, and you'd have to be able to set those values dynamically. Matharuman00 says, how about camera shake effect on the player or the enemy explosions, or if we have a boss entry? Yeah, essentially what you'd need to do is have a reference to the main camera, which you can do with just a public variable that you drag, or you can search out and find the main camera tag. And then you need to have a script that probably is looking at Perlin noise and move towards and that sort of thing. And there's actually probably a number of camera shake scripts on the forum that will shake the camera, and you would get the equivalent of, because we only want to do this in 2D, let's put the game over here somewhere. Where you're doing that. But obviously, you don't want it to be that big. And you see where we're getting some problems here. You might need a wider background. Depends how small you want it to be. Don't forget, we're using an orthographic camera, so there's no parallax perspective. You might want to get into something where you're moving the background and the camera, and the background is using a subset of the camera's moves, so you get a sense of depth. Yeah, you'd have to think about it, because I think that without having perspective, you're going to kind of blow somewhat the feeling of what you've got going on. But you can try something. I mean, remember, you're either going to be moving the camera itself, in which case all objects are going to shake, or you're going to have to find some way to move all of the objects. But it's entirely possible. It's just a question of what we've seen before, is that if you want to move something, you need a script that has a reference to it and then affects the transform. Imaginary Rob is asking, does Unity have a tutorial on switching between scenes, or is there a tutorial on it in the near future? Not specifically, but there are things that you will need to know. There are classes on data persistence between scenes, and you can find those in the live training archive. And there are a number of scenes that use the application load level to do various things, including Space Shooter. When the game is over, where do we have that? It's in Game Controller. Yeah. When game is over, we load the new level. Basically, we're saying application load level, and what are we loading? The same level that we have, because there's only one level to our game. But you could have multiple levels in your game, and then you use the application load level, and then you use either the name or the index number to load your level. Ooh, I've caught up with you guys. So any more questions? Yeah, if you want to give feedback on the section, forum, best place. Teaching, free live online training, questions, feedback, all that sort of stuff goes there. The enemy weapon script is attached to the enemy ship. So when you're looking at the enemy ship, there is the weapon controller that's directly attached to it here. The bolt itself should be slightly more than a dummy. The enemy bolt does have the destroy by contact and the mover, whereas the player bolt just has the mover, but it shouldn't be smart enough to really do much. Yeah, the enemy sound is attached to the enemy ship because we call that when we fire. So the weapon controller does an audio source .play. So that is finding the audio source on the same game object with get component. So the get component finds something on the same game object as this script. And this script is attached to this game object. So it's finding a component that has to be in this list here somewhere on the same game object. So it finds the audio source component and then just simply tells it to play. And it will play whatever is in here. You can do other things where if you had a public audio clip called clip, you could also say audio source dot clip equals clip, and then you can change it. You could have an audio a list if you want something to be random, and then you could say audio clip. Let's make these clips. Same as we did with the hazards equals, clips, index, random range, 0 to clips dot length. And then if we save this and come back to our weapon controller, we now have a random list of clips. I mean, we could put in both of these. Oops, come back here. Enemy ship, lock the inspector, select my 2 weapon sounds, and fill them full of clips. Okay, let's see if we can get as much of this. There we go. Everything's on except for the last bracket. Slash My Wrist asks, is there a best practice for loading screen beside a coroutine and a load async? That's just very successful. I mean, you need something. I mean, you either just wait. It could be a blocking operation, and you load, and you can't do anything until it's loaded. If you want to have the ability to do something while something is loading in the background, then you need to be able to know when that load is done, especially if you want to have a screen that counts up. So I don't see the problem with a coroutine and a load async from as simple a description as that. JuanPa669 says, now how do I change the code of the prefab bolt? Something like over 500 points, the player gets another type of fire. Well, currently, when you look at our fire button, we're instantiating a single shot at a spawn position. Now, what you can do here is have transform shot spawns, and the same sort of thing. We can make this a transform list or transform array. And then what you need to do here is for each shot spawn in shot spawns. So this is the simple part, is that for each shot spawn in shot spawns, you instantiate a shot at a spawn position. So let's save this. So I can come back to my player, and I've got a shot spawn here. Let me frame selected on the player, please. Search. And so here is our shot spawn. Well, let's put it here. Again, we'll take it out of perspective. And let's move this only on the XZ plane. Let's duplicate this. Let's move it over. Now we look at our player, and our player in our player controller has shot spawns. So again, we lock our inspector, grab our 2 shot spawns, add it to, and let's unlock that. So we save. Now, what this should do is give us a twin fire. Oh, what have I done? Console variable shot. Oh, it's because we still monkeyed with stuff. See, I took it apart and I didn't put it back. Bolt. Shot. Save. Play. So now I've got 2. So looks pretty cool. I've got 2 shots now. Whichever way our shot spawn is facing, remember this is true for the enemy ships as well. So if we take our player, just go back to the scene, and let's take that shot spawn and let's duplicate that again, and let's put this back to center, and then back out to where it was before, something like that, you know, in the front. And then we take our player and we add this new shot spawn to our list of shot spawns. And now we take our shot spawns on the outside, and let's call this one shot spawn port. And that one is shot spawn starboard. And then this is shot spawn okay. And just double checking, we've got we've got starboard and bow. So now we've got 3 shot spawns. Back on the player. But these ones, the port and starboard one, let's give it a rotation. I don't know, 21 degrees, 20 degrees, minus 20. And so then this one on the starboard gets 20. Save. Play. I've done something else. I've monkeyed around with this enough that this is, I'm not seeing the, those guys aren't blowing up the way I'd expect. Okay, there we go. Are they blowing each other up? I don't know what's going on. I think they're blowing each other. They're bumping into each other, blowing each other up. There's something weird going on because they're interacting with each other. Because if I move, then so you'd have to debug that a little bit. Now, so you've got patterns. You now need to make a way that you cycle through them. And I'm not going to write that up right now. So you've got to have some logic that looks at what your current power-up is. That will then set which set of spawns are in your current spawn array or spawn list. There's so many different ways that you could do that. So then as you move through power, you would get more things, and you could shoot in circles, you could shoot, you know, in crazy bits. But because you have that for loop, now whatever shot spawn is in shot spawns, you'll shoot a shot from. Cool. Well, I'm going to sign off. Thanks a million. Hope you're all well. I'll see you next time.